On today's episode, we get into the nuts and bolts of building NA power for a Miata, hopefully, ideally. This is where we really assemble all these little puzzle pieces and try to get them to work nice together. So, Stefan, what is really the hardest task or the hardest puzzle pieces to fit together with this engine?
Conveniently, Greg Peters has shown us how to measure VVT advance and piston clearance, so that's going to be the biggest one here. With the head shave, the big cams, the oversized valves, you're in uncharted territory for what's going to interfere. So yeah, we're going to do some work with that. The head needs to be ported, valve job, all sorts of stuff. So we got our work cut out for us. Right along as we hopefully make this all go together.
Let's try to figure this out. Yeah, let's get into it.
So we're taking apart Dylan's head today. This is the 2-liter head you guys have seen in earlier episodes. I wasn't going to take the head apart originally because porting is kind of a nuisance. It just takes a long time and whatnot. But having taken this engine apart as much as we have, we've found some things that are a little concerning about the way the initial builder built it. There's some things that are just like half-assed that with a motor of this caliber should not be.
Oh, there's a big surprise. That's an incredible. I think I'm gonna have a heart attack and die from that surprise.
So I want to take it all the way down to the bare bones. I'm gonna re-plastic gauge everything, check everything out. But for the head, I want to take all the valve train out, and there are gains to be had from porting. So while the valve train is out, might as well port it. On the bottom, you can see right there, somebody like essentially took a grinder and opened that up. I'm probably gonna have the shop do that. I'm gonna bring the head gasket, and because it's a bigger head gasket, so there's room to deshroud it. We'll do all the porting work, and then we'll put it back together once it's done at the machine shop. So we've got the 2-liter head here. It comes with, or it came with, oversized valves, dual titanium spring setups and retainers and all that stuff from SuperTech. They are the 1mm oversized SuperTech valves, both sides, intake and exhaust. It's got all upgraded valve train, and the head, along with the block, apparently, is all 0 mile, brand new. And from the bottom, you can see the oversized valves. Obviously, they don't look a lot bigger because a millimeter, it's only 40 thousandths, not a lot. You can see they've done some machining right here to kind of make sure the valve actually opens. We're probably gonna have the machine shop deshroud all of that. And I'm gonna show you why, even though this head will flow better, why we wanna port it to make it even better. So let's cut to my garage real quick and I'll show you what I'm thinking. The purple here is the runner for the valve. So this is where the air comes in. This is the port where the intake manifold bolts up. The green is the valve, purple is the valve guide, and then red is the air. So the way Mazda cuts these is this is all cast, and then they come in and they plunge cut up through the valve seat to make sure that's all nice and clear. But what they leave is this like sharp radius here, and I'm not like a flow scientist dude, so take my word with a grain of salt. But as the air comes around here, it doesn't like this sharp transition. And if you think about a truck bed, it's a similar concept. As it goes over the truck bed, it curls up in the back, and you get this weird stagnant air here. So what we're gonna do, change that up a little bit and take this section here. Let me erase all of this. And I'm gonna come in with a carbide bit and round that out to make this gradual. That way the air, instead of coming out and over, has an opportunity now to come down towards the valve like this. But you get a better airflow because it's a constant radius instead of a sharp, abrupt edge. But this is the end goal. That's the biggest benefit. This is like maybe a couple horsepower if you do it correctly. Mazda doesn't care about the last couple horsepower. They're trying to do things on a budget. This is if you are trying to go for as much power as you can without CNC porting ahead. This is the best fix right here. This is the goal. Let's go to the basement and take the head apart. You can see it's got all the cam caps off. I took the lifters out at the shop and all that stuff, so those are all gone. The cams are at the shop. Now to take the valves out, so you can see, maybe that one's better. There's a little keeper on this side, like a half circle, and there's a half circle on the other side. That's what's holding, it kind of like clamps around, there's a thin part of the valve. It clamps and chokes that in, and that's what holds the valve to the retainer. I'll show you the whole assembly when it's out. That's what we need to remove. So we need to compress the valve spring, let those pop out, and then we can take them out. Then the whole assembly slides out. It's actually really pretty easy if you have the right tools, which in this case is this guy from Flying Miata. pockets right onto those dowel pins nicely. Tighten these in, and then it comes with this little guy right there. That threads into there, and this whole assembly comes together, and as you tighten this screw, it pushes that down and lets you get access to the valve spring retainers and get the whole assembly out. So really trick tool. I used to do it with a much sketchier version and it was a lot harder. This makes it a breeze. Here's the whole assembly. Valve, obviously. This is a seat. This is not standard. This is definitely from the titanium valves. If you run valves like this with a higher seat pressure on an aluminum head, it can actually like wear out the seat and cause all sorts of issues. So you put this steel seat down, and then 2 valves, which is also not standard. This is just part of the dual valve assembly that lets you rev to like 9,000 RPM. 1 valve goes inside of the other, and then that sits on top of this seat. This is a retainer. This one is titanium. Typically they're steel and flat and they don't have this big drop in. So this is gonna be kind of hard to do. But your valve sits in here like this. The reason you want stiffer springs is because the factory springs at high RPM, like anything above 7,500, they can't keep up with the motion of the valve going up and down, and you get what's called valve float, so your valves will stay open when it's not supposed to. The car just loses all power for a minute. These keepers, which are just like tapered half circles, sit around this. Let me see if I can do it. So the oil's helping me here. So they sit in this little channel, and then they wedge into the retainer. Cam itself pushes down on this top seat here, well, on a lifter that pushes down on the top seat. And I'm probably not gonna be able to compress this a lot because they're really stiff springs, but that is a valve train assembly. And this one is severely upgraded to handle high RPM. So Dylan's engine should be able to rev to 9,000 RPM with this setup. So sandwich bags, individually bag each thing. It takes a couple extra minutes and it is a lifesaver when you are done. So do that. Sandwich bags from Wegmans. If you're an OG, you know Wegmans. The next thing we're gonna do is pop out the valve stem seals. So it's a valve seal remover and installer. This is the remover. It's just this little like half circle thing. I'll put a link to this down below. Super useful. I used to do it with pliers and it was really sketchy, like long needle nose pliers. This thing's great. Slide that over the valve stem seal. Grab, twist, and pull, and you are left with a valve stem seal. Valve stem seals are out. These are definitely Super Tech valve stem seals, which nowadays are okay, but back in the day, and arguably when this engine was built, these are prone to be like bad. They leak oil, all sorts of stuff. So we are replacing them with Viton seals from 5X, and now what we're left with is a bare head. Let's flip it over and I'll show you kind of what I'm talking about for that step cut that I need to get rid of. On this inside edge, it's hard to see, but where that sharp line is where the light stops, it is actually a sharp line that I can feel with my fingertip. And that's the radius that you want to smooth out. It's right there, right in the edge of the valve. So we're gonna grind that out. That's really easy. Every head I port, that's like the #1 thing I do. It's worse on the intake side just because it's a bigger valve seat. And you can see actually right here, somebody's been in with a plunge cutter. I'm gonna smooth this transition out over here, open this up, and really just allow for as much air as possible without like a CNC port. I keep saying CNC port. In the future, I would love to send one. We have like 7 VVTs at the shop. I would love to send one of the VVTs out for a CNC porting job, just to understand the flow gains that can be had there. We have a couple of just spare heads that are sitting around. So if anybody knows anybody who's willing to do some CNC porting work, I'd love to work with somebody on that and understand that and use that head, even for this motor or a motor that we're gonna build in the future. So that was a rough pass, took about 20 minutes. The best way to describe it is I'm trying to get rid of the material that is sticking down from here and out. So this now is like the back of the valve seat and it immediately like slopes out into the rest of the chamber, and you try to make it all even. Obviously you're doing it by hand, so it's a little tough. And you can see how much dust this makes for the record. I'll go in, flip it, do it all over again with sandpaper and really smooth it out and make it look nice. On the exhaust side, that center rib right there, if you knife edge that symmetrically and you think of like a teardrop or a plane, you want the leading edge, which is the intake side, to be rounded, and you want the trailing edge, which is the exhaust side, to be knife edge. If I ever offer to port a head for you, know that I really like you, because this is awful. But there you can see the sanded down port. This is an intake port. All 4 of them are done. Again, I didn't take any extra material off with the sander, just smoothed it all out. Got rid of the like casting nasties. So that is all good to go. Time to switch to the exhaust side. Do this one more time, and then the porting will be complete. That is it for porting and polishing. So that took me, well, I don't want to call it polishing, but it took me 4 hours to get to this point. But that's the finished look. These are the exhaust sides. You can see the knife edge in there. Before this goes to the machine shop is I'm going to reseat all the valves. So all the intake ones are in right now and in their correct spots, so 1 through 8. I've got these power built valve grinding tools, and I just take one end off, chuck it up in the drill because I'm lazy, and I just stick it in there. And I also, on the sealing face of the valve, I put fine metal grinding compound. These were cut. I just want to make sure that I haven't damaged them while I was doing the porting job. So we're gonna do all this, grind them for like 10 seconds each, maybe 10, 15 seconds each. Pop them out, clean them up, and just inspect the seat. And you can put the valves back in and shine a light from the backside and see if you see any light.
Sometimes foreshadowing is relatively obvious.
So I did the intake side. I'm gonna put a flashlight on the back. And you can see there's light coming around every single valve. So I'm wondering, and it's all the way around each valve, which it would not be if I just nicked part of the valve. There would be like a spot. I've done it before. There's like a little piece of light coming through. I'm not sure what is going on. It might be that the previous owner or the guy who built it didn't actually cut the head for these valves. But in whatever case, I'm going to put all the valves in, not all the way in, but just in, and bring it to the machine shop and have him cut it all, seat it all, finish it up. Something fishy's going on there and I don't like it. You can't actually like get those to seat. So I'm gonna leave that to the professionals. And this head's gonna go off to the machine shop.
3 weeks later.
So today we're gonna be working on the bottom end of Dylan's 2-liter engine. There's all sorts of things. I just flipped this over and it's missing the long bolts for the oil pan. So I don't trust anything about it. The pistons hit the valve, so we have to fly cut the pistons. And then we're gonna balance everything from the crank to the piston rod assembly. And then we're gonna put it all back together by the end of this episode and hopefully have a finished bottom end. The first thing we're gonna do is take the pan off and pop all the 4 pistons out. Yeah, let's get to that and pop these pistons out. So pistons rods are out. They're over there in order. And it looks like the crank's been balanced already. There's some dimples that are outside of the factory dimpling. We pulled out a stock crank that we have just sitting in the corner. And it definitely looks like it's been worked on more. Because the guy who put this together has done some sketchy stuff, I'm still gonna bring it to the machine shop and just have him verify it. It does spin well on its own, which is a plus. The next step is I'm gonna pop the oil pump off and then we'll take the crank out and that'll pretty much be it for bottom end disassembly. The only thing I've put back together is the main caps because this has ARP stud replacements for the mains, which means I don't know if this has been line honed when they built it the first time, so we're gonna have the machine shop line hone it. Since it is a fresh build, so what we're gonna do is dingleberry it and just clean them up before I send it to the shop, and then bagged, put it in my trunk, and I'll bring it to the machine shop to line hone this, measure the main bearing diameter, measure the crank, balance the crank, measure the rod diameter, and tell me what size bearings we need. I can do it myself with plastic gauge, but with mics it's a lot more accurate. And with an engine like this, we don't want to cut corners on something like that. So we're gonna take this to the shop and hopefully in a couple weeks have it back and start putting it back together.
Many months later.
So we got Dylan's block back from the machine shop last week, and I've been slowly accumulating parts that we need, new piston rings, wrist pins, circlips, all sorts of stuff like that, and we are finally ready to put it all back together. First thing we have to do is make sure the piston rings have the right gap. You want a gap, that way when the engine heats up, they don't actually butt together, and then you cause like blowout on the side of the piston, and it's catastrophic. You'll need a new engine. We bought new piston rings straight from Wiseco. They're 8550XX, which is just Wiseco's essentially OEM replacement piston ring. I've already done the other 3 cylinders, and actually the bottom ring for this was already good to go. Put this in here, measure it. So what we're actually measuring is the gap here. It's supposed to be 16 for our application, just using Wiseco's calculator. So the 14 fits, so we need to take 2 thou off on the ring filer, and this is just a rinse repeat process until you get there. You want to sneak up on it. So once you file it, put it back in, square it up again. So 15 barely fits, so we got to take more off. We'll just do this until we get to 16, and that'll be all done. So it fits now, but the piston ring filer leaves a little kind of a bird edge. So what we're going to do is just take a jeweler's file and pull away and put a little chamfer top, bottom, and then do the inside, and then lastly do the outside. You don't want anything scoring up the piston walls. So the next thing we got to do, you don't have to do this, but this engine's hopefully going to rev to like 8,500, 9 grand. So we're going to weigh everything and we're going to balance everything together so that the whole rotating assembly is balanced. We already did the crank. The machine shop did that. But now we're going to balance all this, try and mix and match, and then we will, if we have to, take some material off of everything to get it all within the same kind of realm. Ring packs, I've already measured the other 3. They're all very close, so throw it on your favorite drug dealer scale. And we got 21 grams. And now we're just gonna literally go through and measure wrist pins, circlips, connecting rods, all the pistons, mark it all down and kind of do some back and forth math. So we measured all these, separated the weights on that tool, which is also from Amazon. You need to separate the weight from the big end because this is crank driven. So if the crank is balanced, these all need to match on the big end. And the small end, you could technically match it to a piston if they were different weights, but all of our pistons are exactly the same weight. So we have to make all the small ends match so that the reciprocating weight way up top in the stroke is all the same, and then also on the bottom end. What we're actually gonna do is use the trusty sander here. For the small end, we're gonna take material off of this radius here, trying to keep it as uniform as possible. You don't want to just like dig into one spot. So we'll just do some sweep passes on it. And for the big end, good place on these rods at least, there's a lot of extra material on these corners here where the bolt goes through. So we're gonna use that. We're not taking off a lot. This one actually, we don't have to take anything off, but the other ones we gotta take a couple grams off. So don't take material off of this. This is a structural piece. There's a lot of load going through here when the piston is pulling you back down. Corners for the bottom, radius for the top. Now comes the really painful part. I've already done half of them, but the circlips need to go into the pistons on one side. HP Academy has a really good video on how to do this. I forgot the binder clip, so I did it by hand. This guy right here is now inside of one side of this, so I can still slip the wrist pin through one side, which is important because we need to put the connecting rods on. Quick note about connecting rods, at least on a Miata, and I'm pretty sure this is true for everything. The tangs where your bearings line up always go on the intake side because that's the unloaded side as the engine assembly is coming back around. So in this case, the tangs are on the right when you're looking at the Manly logo. So on the intake side, this assembly would sit in here like this, and we're just gonna repeat that 4 times over. I've used assembly lube in all the bushing holes, both on the piston and the rod, and then I also lube the wrist pin itself. I use Lucas stuff or Redline's assembly lube. This stuff, it seems to be a lot stickier and like stays around for longer, so I'm a fan of this now. Pistons and rods are assembled. Next thing we gotta put the crank in. We're gonna technically put it in twice because I'm gonna plastic gauge it. We did have the crank and the main caps and actually the rods all measured to make sure that everything was in spec and that we could run standard bearings, but it's always good to do a double check. I've already put 2 pistons in, but we're gonna put the last 2 pistons in, 2 and 3. First things first, we gotta put the rings on. So Wiseco actually sends like a how-to because the orientation is very important. You don't want them all to line up because then all of your compression is gonna go through there. To install it, if you don't have one of these, just spend the 60 bucks. Instead of using the clamp compressor to put the piston rings in. I'll show you when I use it, but you drop the piston in, you push it through, and then you just set it into the bore, and like it never fails. So I've got one now because Dylan needs to be extra with his bigger piston set, and I've got the standard Miata ones too. Lifesaver. They're made by Wiseco also. So we got Dylan's head back from the machine shop finally, and we're gonna do a test fit. Since we machined the pistons on the intake side, we need to make sure we have clearance, and now with this spicy Marua adjustable exhaust cam gear, we need to fully advance and fully retard it to make sure that we have plenty of room on that side as well. And then we'll put it all back together one more time, and that'll be it.
No! God, please, no! 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 No!
We put the head on without the head gasket, so we're running a 30 thousandths head gasket, and it nicked like it did before we machined the pistons, which was a risk because as you shorten the head, the valve essentially moves out when it's opening. So we put the head gasket back in thinking it was going to be enough to move it back over, and it wasn't. It hits like I feel like if it spun over once, it would probably just shave off the little bit that it needs. I don't want to take these pistons apart again, and I don't want to wait another 9 weeks for the slowest machine shop ever. So I'm going to, well, I think you kind of get the gist. I've marked off, taped off everything. All the oil ports are closed. There's earplugs and everything over here that contains oil. And I'm going to just lightly open up the ring surface where it was touching, and then we'll put it back together. I'm not going all the way down like the machining was. I'm just gonna put like a 45 on it because it doesn't need a whole lot. Valve goes this way, piston goes this way, so that it's actually like 26 degrees, but that angle is what I gotta open up. So I'm gonna slowly Dremel these 4, we'll spin it over, I'll tape off the center 2, and then we'll test fit again. Wasn't as bad as I thought, so did all 8. It's not the prettiest thing ever, but like obviously compared to a machine, it's not going to be the best. So we're going to test fit it now, and if it fits without a head gasket, it will fit plenty with a head gasket. So we're going to recheck all this when we get the right shims in, just to make sure we don't have any unforeseen issues, but for now, let's just let's
Fingers
try.
crossed.
Emotional, damn it!
That's right, folks. First go around did not work, but Stefan was a champ. He went back, did another pass, got everything working properly, and prevailed. Now back to you, Dylan, for the outro. Well, it's together. What was really like the biggest frustration for you?
The biggest frustration for me, I think, has been supply chain. So big shout out to Daniel and the guys over at Boffy, because they were able to find all of the parts we needed, whether it was like open box stuff that just happened to work. This engine would not be where it is right now without their help. So
the Spirit Guides continue to light our path through the darkness that is this build. So,
and it's not just something they provide to us. Like we've been talking to Daniel back and forth like all of the time, literally. And if you have questions, they're always super resourceful. They've answered all our questions, and if they don't know it, they'll find out for you.
There's not a ton of companies in the US that do ITB stuff. So if you want like an ITB kit, that's what we've got here. We're going to get more into depth on that kit and the specifics the next episode. But they are a great resource that I don't feel like we have many of here in the States.
Yeah. And they're overseas, but shipping from there takes just as long as shipping from California to here.
What was the last thing we ordered from them?
Within like 2 or 3 days, it gets over here, including customs, which is astounding.
Yeah.
Worth noting, they don't drop ship a lot of stuff, so they actually have it in stock, and if it shows in stock, they've got it.
So as always, thanks for watching. Next episode, we're putting the engine in and really going over a lot of the custom bits. We've talked a lot about the engine itself, but we have some stuff coming and a lot of stuff planned. Stefan's going to be flexing with that welder. Stay tuned for that. I think next episode might be almost like my favorite to talk about of all those custom things. So we'll go over that. So subscribe down below to follow along. And again, thanks for watching.
Mom says I'm handsome.
Existence is pain. I'm Mr. Meeseeks.
I want to die. We all want to die.
You're good.